We began this unit by looking at equivalent fraction, the idea of a fraction being the same even though it has a different denominator. And then we used that knowledge to be able to compare fractions. So unlike fractions with different denominators, we were able to change so that they became like fractions, or we could use a fraction rule. And we could decide which one was bigger, which one was smaller, whether they were the same size. And from that we were able to move on to ordering fractions, so going from smallest to biggest using a number line. So before we start today's session, I just want us to recap on that learning that we've done previously, and especially in our last lesson where we looked at comparing and ordering by completing these two sentences. I find it easy to compare fractions by. What is it that makes it easy for you to compare fractions? What sort of things do you find? If it does this, then it becomes very simple. And then the second sentence is, I find it tricky to compare fractions when. So if I put a load of fractions up on the screen right now, which ones would you be going? That's going to be a difficult one to compare, and this is the reason why. So I want you to pause the video, I want you to think about these two sentences, and I want you to complete them. So it's entirely up to you how you answer them, because something I find easy or something I find tricky might be completely different to you. So there's no real right or wrong answer to this. So sentence 1, I find it easy to compare fractions by doing something. What is it that you find it easy to do in order to do that? And I find it tricky to compare fractions when this happens. So when fractions might look slightly different or something. So complete those two sentences, pause the video and come and join me when you've finished answering those. So now we've reviewed our previous learning, we're going to move on to today's session. And in today's session, we're going to try and answer this question of how do I add like fractions. So in this lesson, what we're going to be looking at is adding two or more fractions, and they're going to be like, so it means they've got the same denominator. And going straight to our textbook, we can see that our first problem relates to a birthday party and the pizza that Zach and Isla have been eating. So for question 1a, we're asking altogether what fraction of pizza is remaining. And in order to be able to answer this question, look at the pizzas first. How many parts have the pizza been broken into? How many equal parts has that pizza been sliced into? Because that's going to give you an idea of where to start. Then once we've found that out, what fraction is left in the first pizza box and what fraction is left in the second pizza box? And then finally, you're going to be able to use this word altogether to help you to work out what to do. So for question 1a, be thinking, how many equal parts is each pizza broken into? How many of those parts are remaining from each pizza? And what does altogether mean? To help us answer this question of 1a, altogether, what fraction of pizza is remaining? And for question 1b, you're asked to use a number line to show this answer. So I want you to pictorially represent what you're doing, just to prove that your answer is correct. So for question 1a, your question is, altogether, what fraction of pizza is left in the boxes? And then for question 1b, I want you to use a number line to show your answer. So now you're ready to answer those first two questions. Pause the video, go and work it out, and then come and join me when you're ready to discuss the strategies that we've been using. So let's start by looking at what we did for question 1a. Altogether, what fraction of pizza is remaining? And our first thing is to look at these pizzas. And as we said, how many parts has each pizza been broken into? Well, if we look really closely, we can see that they've sliced it into 10 equal slices. So originally when that pizza arrived, there would have been 10 slices for each box. That instantly tells us that we're going to be working with a denominator that's going to be tenths or 10. So now we know that we're working with tenths. Our big question now is, well, what fraction is actually left? How can I work this out? And using our bar models, we can instantly see what fraction of these pizzas is remaining. So if we start with our first pizza, the one at the top, we can see that 4/10 of that pizza are remaining. If we look at the pizza at the bottom, we can find out that 3/10 of this pizza are remaining. So we can see that from these two pizzas, the pizza that Zach has, he's got 4/10 left, and the pizza that Isla has is 3/10. The next thing we were asked to look at is this idea of what does altogether mean. And we know that altogether means you're going to put it together. So the 4/10 and the 3/10 are going to be together, and that's the fraction of a pizza that is actually remaining. So now I've used my bar model and I've shaded the 4/10 of Zach's pizza, and now I'm going to shade in the 3/10 of Isla's pizza. So now we can see how much pizza we've got all together remaining. The 4/10 of Zach's and the 3/10 of Isla's. And if we add these two amounts together, that gives us the total amount remaining. So 4/10 plus 3/10, as we can see from the bar model, gives us 7/10. So for question 1a, altogether what fraction of pizza is remaining? The answer is 7/10 of the pizza is remaining. Then for question 1b, I'm asked to use a number line to show my answer. So I'm going to use a number line to show this working out now. And we've already been able to work out in total is 7/10, and I can speed up my process, not needing to draw the bar model, use a bar model. I can simply use a number line to do exactly the same procedure. So we start off with Zach's, and we worked out that he had 4/10 of his pizza left over. And then we've got Isla's 3/10 of pizza. And we can add that on as well. And here we can see, using the number line, we get exactly the same answer. We've got Zach's 4/10, Isla's 3/10, put them together to get that all together, adding them, and you end up with 7/10 of the pizza left. Alternatively, if I wanted to, I could count each individual slice of pizza in the knowledge that each of them is going to be one of those 10 equal parts, 1/10. And here we can see that Zach's pizza is shown. We've got 1/10, then another 10th, then another 10th, and another 10th to give me 4/10. Then I have Isla's pizza, 1/10 and 1/10 and 1/10 to give me 3/10. Put all those together, 4/10 and 3/10, and it gives me that answer of 7/10. So to use a number line to show your answer, this is what we'd be looking at. You're simply just counting on in the denominator you need, so counting in those unit fractions. So when working with these fractions today, be thinking about what denominator you're going to be looking at and how you can put those two fractions together using those counting on methods. And now we've managed to work through those first problems together. Now it's time to continue with the work in the textbook before moving on to your workbook to complete independently. So be thinking about the different strategies we've been looking at, the idea of counting on should you get stuck, thinking about your bar models, thinking about your number lines, really see what your answer is going to be to prevent you making any of those mistakes. Remembering, if I have 1/2 and I add another half to it, I have 2 halves. I'm not going to end up with 2/4 because it means it's a completely different fraction. So be thinking very clearly when you're drawing the bar model, break it up into that denominator and add in your fractions. So good luck, and I look forward to seeing your work.